Here they tell you that h is defined as this function f divided by g, but that the derivative of it is just f prime over g. So that should seem kind of strange, because if h is f divided by g, then wouldn't you need the quotient rule to take the derivative of it? So let's see what happens if you do the quotient rule. So wouldn't it be bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared? And now they're saying that this equals f prime over g. So if that's the case, then, well, let's just like try to use this equation now and solve it for g, because that's what they're asking us to do. So we can multiply both sides by g squared to try to get that to cancel. So if we multiply this by g squared and this by g squared, then do you see how like that would cancel? So then we have g times f prime minus f times g prime. And then here, one of the g's would cancel, and you're just left with f prime times g. So now, let's try to like simplify this. So I have g times f prime, and then g times f prime on this side too. So I'm gonna like subtract that off. And you see how then you're just left with negative f times g prime equals 0. Well, so if two things multiplied equals 0, then one of them's got to be 0, right? But they told you that f doesn't equal 0. They told you that it's always less than 0. So it's got to be g prime that equals 0. Well, if g prime is 0, then like think about what kind of a thing has a derivative that's always 0. The only thing that does is a constant function. So the only one of these that's a constant is this last one. So g has to be 2. And then you also know that it's 2 because they told you that like g of 5 is 2. I know that one was super confusing. I haven't really seen a question that hard in a while. So don't freak out if it was really difficult for you. All right, so now let's move on to number 3. So at what point on the graph of y equals 1/2 x squared minus 3 over 2 is the tangent line parallel to this line? So lines are parallel when they have the same slope, right? So let's find the slope of this line. So in order to do that, I'm just gonna like rewrite it as y equals mx plus b. So subtract the 4x over, divide by -8. And you see how the slope of this line is 1/2. So then I want the slope of the tangent line to be 1/2. So isn't the derivative the slope of the tangent line? So I'm going to take the derivative of this, which ends up being just, bring the 2 down, cancels with the 1/2. So that's just x to the 1, and then the derivative of this constant 0. So the derivative of this, the slope of the tangent line, is just x. So I want them to be equal to each other. So then I know that the x value's got to be 1/2, so it's not these 3. And then I just have to figure out, like, well, distinguish between a and b. So I just have to determine, well, what is the y value when x is 1/2? So I'm just going to take 1/2 and plug it back into the original function. So 1/2 times 1/2 squared minus 3 over 2. And so 1/2 squared is 1/4. 1/4 times 1/2 is 1/8. Minus 3 over 2, so I'm going to find a common denominator now. So I'm going to like multiply by 4 over 4. So that's minus 12 over 8. So that ends up being -11/8. So that's why it's b. All right, so now let's look at this next one. So I don't think that 3 was tricky, but it's not like crazy hard, not as hard as 2, in my opinion at least. All right, now number 4 is pretty hard. I think it's a little, maybe in between the other two. So here they're telling you that f is continuous and differentiable. So in order for something to be continuous, a piecewise, that means that the two pieces meet up. So if it's continuous, then when you plug in 2, you get the same thing for both of these. So let's try to do that. Let's plug 2 in for x into the top equation and the bottom equation, and then set them equal to each other. So here, 2 to the 4th is 16. So you get 16a plus 10 if you plug 2 into that part. And that's got to equal, well, if we plug 2 in here, that's 4b minus 6. So this is one equation that's true if the function is continuous. Now let's see what's got to be true if it's differentiable. So that has to do, differentiability has to do with its derivative existing. So let's take the derivative. So that would be 4a x cubed. Remember, a is just a constant in the front, so it'll just kind of stay there. And then the derivative of 5x is just 5. And then, so that'll be the case when x is less than or equal to 2. And then the derivative of the second part is 2bx minus 3. So now if it's differentiable, then doesn't that mean that the slope from the left and the slope from the right are the same? So we're going to plug 2 into both of these and see what equation we end up with. So if I plug 2 into this, 2 cubed is 8. 8 times 4a is 32a plus 5. Now I'm going to plug 2 into this one, so that's 4b minus 3. Won't they have to be equal to each other if it's differentiable? So now I have two equations. So it seems like I have two equations, two unknowns. Seems like I should do a system of equations. I know you guys haven't done that in a while either. So I'm going to try to like set it up. Like, see how there's a 4b here and a 4b here? So maybe like I can use elimination to solve this system. So I'm just going to bring the a and the b to the same side. So here I'm going to like, I don't know, bring the 32a over. And then I'm going to bring like the 3 to the other side, so that's going to equal 8. And then here I'm going to bring the 4b over and then the 10 this way. So I get 16a minus 4b equals negative 16. It doesn't really matter. And then I'm just going to bring this over here. I'm just going to write the 8 on this side instead, so I can line them up nicely. So I kind of did it in a way that like made these cancel. If you want to do it in a different way, that's fine. I mean, however you want to solve a system, it's no big deal. You know, you could even like use substitution, solve this bottom or this top equation for b and then plug it into the other one. So here I'm just going to add these two equations together, and you get negative 16a, those cancel, equals negative 8. So now we know that a is a half. But I think that the question, of course, asks you for the value of b. So let's go back and plug this a into one of these equations. I'll plug it into this one. So 8 equals negative 32 times a half, isn't that negative 16? Equals 4b. So I'm going to add the 16 over, so then I get 24 is 4b, and then divide by 4, so then b ends up being 6.